In today's lesson, we are going to revisit many topics that we've already talked about this year. However, we're going to take another look at them now that we have been coding for about 2 months now, and we have good ideas about the backgrounds for these different ideas. All right, let's start by talking about what is called a driver program. Now, a driver program essentially drives the use of other more interesting parts of a program. So typically what we're going to do is we're going to create at least one, if not more, classes. And then we're going to have a driver program that will essentially interact with those programs. So the driver program will create objects and interact with the user. And the driver program is unique because it has the main method. This is the only Java file within the ones that are working together that will have that main method. And that is the code that the computer executes when you go to run the program. It runs the main method. Now, our programs are going to have more than one method, and when we define a new method, we use what's called the method declaration. And this essentially specifies the code that's going to be executed when this method is invoked or called. Now, when a method is invoked, we say that the flow of control jumps to the method and executes this code. And when it's completed, the flow returns to the place where the method was called and continues. So you can kind of think of it like, well, where is the cursor currently? So for example, if I were to have, code, and then I had a method call, I would come over here, I would execute the method call, and then when I was all done, I would return where I left off and continue with more code. So essentially, a method is just a chunk of code that is bottled up and described somewhere else, and then when we call it, we simply just use the method name. Now, a method may or may not return a value. It just depends on how we want to use the method. Now, on this slide, we talk about the flow of control. And so there are a couple different ways that we can write a method. The first way is that we can write a method within the same class. And when that method is written in the same class file, and when we say the same class, we mean in the same .java file. So when this happens, we only need the method name to call it. So here I have a class, and I'm doing my code, and then I encounter my method, and then I come over here and I do all the code in my method, and then when I'm done, I come back to where I left off and continue on. Notice that when I called this method, I only had to use the method name. I didn't have to refer to it in any other way. Now, that's not always the case. If, for example, I was trying to call a method that was in a different class, it would look a little different. So here's another example of how our method flow of control can look. In this case, I have two different methods that I'm working with. So here I have a method that is part of another class. So if it's part of another class, we can invoke this two ways. One way we can do it is we can invoke it by the object name, and we've seen that before when we've used our method, our string class methods. Or if the method happens to be static, then we will invoke it by the class name, and we've seen that when we worked with our absolute value method or any other methods of the math class. So in this case, I have my main method, doing my code, and then I encounter this method call obj.doIt. So based on what I see here, I can tell that doIt is a method that is in the class that this object obj is a member of. So when I call this method is actually being invoked by this object. And so over here, I have my doIt code, and the doIt now makes a call to another method. Now, when I see this method call doesn't have anything in front of it. So that tells me that this method code is inside of the same class file that doIt is part of. And help me now comes over here, does its code, When it's done, it returns back over here. And then now I finished doIt, Don't you love these sound effects? And then when I finish doIt, now I go back to where I was called. So essentially we can think of these methods as taking control of tasks for us. we're kind of like passing off the responsibility. We're saying, you know what, here's a bunch of work, I want you to go and do it. So go do it. And then do it says, well, I'm going to call this method to help me out. So help me. And every time you call the method name, you invoke the method and that code is executed. Now, when we're working with methods, we have to understand how to define them, how to write them, and then how to use them. So let's first take a look at the method header. Now, our method header is what begins any method declaration. And there are several things that we are going to see here. First and foremost is the return type. Now, if a method returns nothing, then we would write void if it returns nothing. Next, this here is the method name, and that is what's going to be used when the method is called or invoked. After that, we have parentheses, and this method happens to have 3 parameters. It's possible that a method has no parameters, and if that were the case here, it would say calc open close parenthesis. And the order of these parameters makes a difference. It defines how the computer is expecting you to call the method. So the parameter list is going to specify the type and name of each parameter. And the name of the parameter in the method declaration is what we call the formal argument. And the way that I think about this is formal is how it is officially going to be called inside the method code. So if we look at the next slide has the code that goes with this method. And you will notice here that these formal parameter names are the names that are referred to in my actual method body code. So regardless of what the person might have used when they called the method, these are the variable names that are actually going to be used in the method. And that's why they're called the formal parameters or the formal arguments. Now, the code that is inside these curly braces is called the method body. And if our method header says that we return something, then we must have a return statement. If our method is a void method and it returns nothing, then we do not need a return statement. Now, it's important to realize that returning is not the same as printing, okay? So this is not the same as printing. And that is a common mistake that students make. When their instructions say to write a method that returns a value, instead of returning it, they just print the value. And that's not what's supposed to happen. That actual answer is supposed to be sent back to the calling program. And it's important to note that the expression must be consistent with the return type. So notice here that this variable result is of type character, and my return type is of type character. And those must match. If they don't match, then it won't work. Now, another thing that I want to point out in this method is what are called local variables. So here, sum and result are local variables. These variables are declared in the method, they are used in the method, and when the method is done, they are destroyed. They only live and exist in the method. So these are considered kind of like temporary variables because they are solely created for the purpose of the method. Now, the return type is going to indicate the type of value the method sends back. Again, a method that returns nothing is void, and the return statement specifies what's being returned. So return something. And this expression has to match the return type. Now, you can have it return a number. You could have a method return a Boolean, if I spell it correctly. You could have a method return an expression, 5 times 2 plus 3. You could also have a method return an inequality, such as that. So this part here that says expression can really be anything. It can be a variable name, it can be a value, it can be a mathematical expression, it can be a Boolean comparison. The only criteria is that it must conform to the return type. All right, so again, let's come back to these parameters. So there's two different things we talk about. We talk about the actual parameters and we talk about the formal parameters. So the actual parameters are what you actually pass in when you call the method. And the formal parameters are what the name is formally described in the method. So that is what we actually see in the method when it is being used. So if we were to draw variables to go along with this, we are essentially saying that when this method starts, we are creating variables num1, num2, and message. So num1 is an int, num2 is an int, and message is a string. So we're going to have this pointer. And then when I call it, the value 25 is going to be copied into num1. Whatever value is in count will be copied in there. And then message will refer to the string hello. So those are new variables that are created simply for the purpose of this method. Another thing that we'll see are preconditions and postconditions. So a precondition is a condition that should be true when the method is called, and a postcondition is what should be true when the method is finished. And these are common expressions that the AP test uses to basically tell you what to expect when the method starts. A common thing would be saying, for example, that A is greater than 0. So that would mean that you can assume for the entire method, that A is less than 0. You can assume for the entire method that A value is negative. This is basically just telling you that starting information, what you can assume to be true. If we think about this in relation to geometry, a precondition is like your given statement and a postcondition is like your prove statement. All right, we're almost done. Constructors. So a constructor is very important, and up until now, a lot of us don't really understand the purpose for them. So a purpose for our constructor is to initialize a newly created object. So things to remember, number one, our constructor name has to have the same name as the class. It has no return type, not even void, and it's going to set the initial values for the instance variable. Now, the programmer does not have to define a constructor, but it is considered best practice to do so. So that's what we are going to expect of you guys. So there's local data essentially refers to variables that are declared inside a method. Now, formal parameters, when we call a method, automatically create these local variables when the method is invoked. All right, so what does that mean? If we look back to this slide we saw a minute ago, num1, num2, and message, those are the formal parameters. So when I call this method, the computer is going to make 3 local variables for me, and when the method is done, those variables will disappear. Now, it's important to remember that instance variables are declared at the class level. These exist as long as the object exists. So when we say at the class level, those we are going to declare outside of the constructor. And so they are essentially like global variables, for those of you that have learned about global variables before. And any method in the class can refer to these instance variables because they have global scope. All right, last but not least are the accessor and mutator methods. So we want our instance variables to have private visibility so they can only be accessed through methods. So we have 2 methods that we use. We have our accessors and our mutators, and these are typically our getters and our setters. And so if our data value is called x, we would call these methods getX and setX. And if you recall, we showed you how in Eclipse, if you go to the source menu, then there is an option to generate your getters and your setters, and you are allowed to use this feature. So after you've set up your class and you have all your instance variables, you can go ahead and do this, generate getters and setters, and it will take care of it for you. Also, for getters and setters, you are allowed to have a block comment for all. Basically meaning you don't need to do method headers for every single one of them. Just do one general method header that you are doing your getters and your setters. All right, that's it for today.